Here's our first example of a rational equation that's a little more complicated. And what complicates it is the fact that the variable is in the denominator of the fractions. We've dealt with situations where there were numbers in the denominators, but now we have the variable in the denominator. So we have to, actually, because of that, we have to worry about something here. Remember, what number can we not allow to be in the denominator of a fraction? That'd be the number 0, right? If 0 is in the denominator of the fraction, what, worlds collide, black holes open up, swallowing the entire universe? Or you would think that was the case because mathematicians always tell you you can't have 0 in the denominator of a fraction. And that's because there's no answer to that problem. There's no answer to 20 over 0. There's no number that equals 20 over 0. So we couldn't allow x to be 0 because it would make these two denominators 0. But also, what couldn't we allow x to be here? Because if we put it in there, it would make that denominator become 0. Wouldn't that be negative 5? So there are some restrictions on what x can become. So if, as we solve our equation, if we get those restrictions, we're going to have to throw that away and say the equation does not have a solution. So the two restrictions here are x can't be 0, x can't be negative 5. So let's solve this equation. We have to find a multiplier that will cancel out the denominators. Well, wouldn't that take, for this fraction right here, wouldn't that take a multiplier of x plus 5? Wouldn't I need the entire binomial to cancel that entire binomial that's here in the denominator? But of course, I can't just multiply this fraction by something and multiply the others by something else. That destroys my equation. So that means if I need to multiply this fraction by x plus 5 so as to cancel the denominator there, I'd have to multiply this fraction by x plus 5. And I'd have to multiply this side of the equation by x plus 5. Now, let me ask you this question. Would the x that's here in the binomial x plus 5, would it cancel the x that's here? In other words, if we had this, x plus 5 over x, can we cancel those x's? I trust you said no. And the reason we can't is because this x is tied up with addition, and we can't cancel that way. That would be like saying 6 plus 5 over 6 is equal to 5. And we know that's not true. 6 plus 5 is 11. That's 11 sixths. That's not true. You can't cancel like that because this 6 is tied up in addition. So this x can't be used to cancel that x. We will have to have a separate factor of x. Remember, factors means you're multiplying. Then you can cancel, can't you? You can cancel when you're multiplying. But if I need the factor of x to cancel here, and I also need the factor of x to cancel there, don't I? I'm going to have to include the factor of x there. I have to multiply every term of the equation by the same quantity, or I destroy my equation. So this factor of x and binomial factor of x plus 5, that pair of factors, that pair is the correct multiplier so as to cancel my denominators for me. Let's see how that's going to work. When I multiply here, the binomials can cancel completely, just leaving me 12 times x, which is 12x. Here, the x factors cancel, leaving me 5 to be multiplied, and it's a plus 5, isn't it? A plus 5 to be multiplied times both those terms of that binomial. So that's plus 5 times x, which is plus 5x. It's plus 5 times plus 5, which is plus 25. Here, the x's also cancel, leaving us 20 to be multiplied times both terms of that binomial. 20 times x is 20x. 20 times plus 5 is plus 100. And we've removed the fractions that were in that rational equation. There's some like terms I could combine here. 12x plus 5x is 17x. I can subtract 17x from both sides, and then subtract 100 from both sides, and dividing by 3, I get x equals negative 25. What did we say were the restrictions on x here? We said that x couldn't be 0 because it would make this denominator 0. X couldn't be negative 5 because it would make this denominator 0. We got a solution of x being negative 25. So at least we can accept that solution as not being one of the restricted values on x. We really don't know whether or not it's the correct solution until we would plug it in and see that it made the left side the same as the right side. That, or hope this was an assignment out of a textbook where we have an answer.